This is my grandfather, Earl Carmichael. He spent most of my childhood dying of Alzheimer's disease. I have very hazy memories of playing with him and talking with him when I was a little boy, and I have very vivid memories of the end of his life when I was 15, and he could no longer form complete sentences or recognize members of his own family. This is my father, also named Earl Carmichael. He was clinically diagnosed with Alzheimer's disease about 2 or 3 years ago. So he's still in the relatively early phases of the disease, which means more or less that he has some good days and some bad days. But I know what's coming for him in the future. And these are my kids, ages 6, 5, and 2. As an Alzheimer's disease researcher, I have been granted the privilege of being able to spend most of my workday trying to prevent what happened to these 2 gentlemen from happening to these 3. And of course, it's not just about my own kids. There are millions of people living with Alzheimer's disease right now. That number is steadily going up over time. And some of the people who get it have it in their family tree, like I do, and some people do not. Anyone can get it. Where are we in the fight against Alzheimer's disease? Alzheimer's disease is caused by the buildup of certain abnormal proteins inside the brain. And to date, vast amounts of time and money and treasure have been spent on 2 basic approaches to fighting the disease. One is to try to break down those abnormal proteins and get them out of the brain if they're already there. And the second is to try to prevent those proteins from building up in the brain in the first place. I, for one, will be overjoyed when either one of those 2 approaches pans out and bears fruit. But I am sorry to tell you today that there, at this moment, are no clinically proven therapies that either prevent the abnormal proteins of Alzheimer's disease from building up or break them down once they're already there. But maybe, just maybe, there might be a third way. Let's say the abnormal proteins of Alzheimer's disease have built up inside the brain. Maybe we can fortify the brain so that it doesn't succumb to the devastating mental losses that result from those proteins. Maybe we can bolster the brain so that instead of falling victim to the mental losses of Alzheimer's disease, it's able to push off the damage. It's able to push it off into the future, giving people many more years of quality life and mental health to spend with their friends and loved ones. Maybe, just maybe, we can train the brain to defy Alzheimer's disease, to resist. Now, this idea that Alzheimer's disease is something to be resisted may sound crazy. It is only ever presented to anyone as this kind of overwhelming force that picks up its victims and carries them away. But consider the following. These are 2 brain scans of 2 different individuals, A and B. In each picture, you'll see an upside-down U shape on the outside. That's the skull. And inside the skull, you will see this gray stuff, which is brain tissue, the tissue that is used to produce thought. Person A is a healthy young individual. And what you should notice is that that gray stuff in the middle fills up pretty much all of the space inside the skull. Person B looks different. There are these black spots. Those are gaps where brain tissue used to be before it died. This is a person that's lost a significant amount of brain tissue. And if brain tissue is the thing that you use to think, it makes sense that the person in scan B should have serious mental problems. And indeed, person B has been clinically diagnosed with Alzheimer's disease. Unable to remember facts that you tell them, having a hard time keeping up with that conversation you're trying to keep up with them. It's as expected based on their brain scan. But now consider this. This is a different person in scan B, and it should look similar to the previous one to you, in that there are big, black, empty spots, places where brain tissue used to be before it died. Again, you would expect that the person in scan B would have serious mental problems based on the fact that a lot of their brain is missing. You would expect this person to have Alzheimer's disease. The problem is, the person in scan B is perfectly mentally healthy. They can remember facts that you tell them. They can hold down their end of a conversation. They're fine. And this isn't just a limited anecdote observed one time by my colleagues at UC Davis. Research centers around the globe have examples like this. Brains that just scream Alzheimer's disease, open and shut. And yet, the person with that brain is fine. What do these people have going on? What do they got? And more importantly, how do we take what those people have and spread it around a little bit? Well, the short answer as to what those people have going on is unsolved. And in fact, at the Pennington Center in Baton Rouge, we are embarking on new research projects to try to answer this very question of what those people have going on. And the short answer is we don't know yet. But there's one theory that has to do with the electrical circuitry that connects the brain together. The brain is a very complicated electrical circuit, and electrical signals flowing through that network is the activity through which thought arises. The biological wires of that network are called neurons. They're shown in this picture in orange. So it could be that some networks are able to tolerate a certain amount of disruption and still be able to function properly. Alzheimer's disease kills and disrupts those biological wires, which causes the mental problems of the disease. But it could be that some brain networks are able to tolerate a certain number of its wires being zapped by Alzheimer's disease and still function okay overall. Think of the electrical circuit of the brain, the electrical networks, as being like a highway network in a city. In the same way that electrical signals flowing from point A to point B gives rise to the functioning of the brain, so do cars flow from point A to point B, and there's a functioning of an entire network of highways. Some cities have highway networks that are able to tolerate a certain amount of disruption. So if there's an automobile accident in one highway in one part of the city, traffic is able to efficiently reroute itself around it. And by and large, if you take the overall view of the entire network, it's still functioning more or less okay. More or less, most of the people in the city are able to get from point A to point B via this highway network. And then there are certain other cities where one wreck in one part of town turns the entire city into a big parking lot. Networks like this lack something. It's either not enough highways, or the highways are connected from the wrong place to the wrong place, or there aren't smart interchanges, or something. But one disruption in one location seems to grind the whole network to a halt, and overall, the entire network ceases to function properly. So one theory is that in people who are able to resist Alzheimer's disease, their brains may be more like the first kind of network that has been built or wired together in such a way that they're able to tolerate a certain amount of the disruption caused by dead neurons caused by the disease. So now, one of the questions of the moment is, and this might be something that you're contemplating right now, is there anything I can do to help my brain resist Alzheimer's disease? And the short answer is, this is still another research question of the moment, and we're not entirely sure. But the initial hints are that the same health factors that we would try to promote anyway for a variety of other reasons might actually help the brain resist Alzheimer's disease. Doing things like staying physically active throughout your lifespan, eating right throughout the lifespan, staying socially connected, staying intellectually engaged. These are all things that appear to have some role in fortifying the brain so that it's able to resist Alzheimer's disease. Now, these are all things that you would have done anyway, and that your doctor would have told you to do anyway for a variety of other reasons. But now, what if the stakes are this high? What if doing these things actually helps set you up to fight Alzheimer's disease when you're very, very old? That's the question. And that brings me back to my kids. I don't think my wife Kathy and I are really any different from any other parents out there. We spend a great deal of our time and our energy and our effort trying to set our kids up for success in the future. We try to get them to eat right. We try to peel them off the couch, get them to exercise. We try to get them to try hard in school, just like any other parents out there. And when we do, just like any other parents, we're thinking about what tools and resources they're going to have at their disposal at certain points later on in their lifespan. So when we're doing these things, I'm thinking about my kids' first day in college and what they're going to have in their toolbox to use. I'm thinking about their first day at a new career, at a new job. I'm thinking of that first day when they decide to start a family or join some community. What are they going to have at their disposal? But now, more and more, we're starting to think about points in our kids' lifespan that come way, way after that. Long after Kathy and I are both gone. We're asking ourselves whether we're setting our kids up to resist Alzheimer's disease should it come for them. Thank you.